There is a question that naval historians have returned to many times in the decades following the Second World War. How did a fleet of small, lightly constructed wooden vessels manage to reshape the operational calculus of one of the most formidable naval powers of the 20th century? Not through a single dramatic confrontation between great armadas, not through technological superiority in the conventional sense, but through an operational method so unconventional, so structurally mismatched with existing countermeasures, that the Imperial Japanese Navy spent the better part of 2 years developing a coherent response to it. The answer lies in the Solomon Islands, in the narrow straits between volcanic peaks, in the darkness that both sides once competed to control. And it begins not with the boats themselves, but with the problem they were designed to solve. This video is presented for historical and educational purposes only. By the middle of 1943, the Allied naval position in the central Solomon Islands had settled into a recognizable pattern. The United States Navy held advantages in radar technology, in overall tonnage, and in the capacity to produce and replace vessels at a scale Japan could not match. Yet, in one specific operational environment, the confined, reef-threaded waters between the major island groups, navigated primarily at night, those advantages were difficult to translate into results. Japanese surface forces, particularly their destroyer squadrons, had developed a practiced efficiency in nocturnal operations. They moved supply convoys through these passages with regularity and relative confidence. Allied cruisers and destroyers designed for open ocean fleet engagements were less suited to this kind of close-quarters night navigation work. The geography itself constrained what larger vessels could do. The supply runs that Allied planners called the Tokyo Express were not simply a logistical inconvenience. Each successful run delivered troops and material to Japanese garrisons, extending the operational range and defensive capacity of a network of island positions that Allied ground forces were working to dislodge, island by island, across the breadth of the Pacific. Disrupting those runs was not a secondary objective. It was central to the campaign. What was needed was not simply more firepower, but a different kind of platform, one suited to the specific geography of the Solomons, capable of operating in shallow and reef-complicated waters, and fast enough to disengage before a conventional naval response could be organized. The patrol torpedo boat, designated PT in U.S. Navy nomenclature, had been in development since the late 1930s, drawing on British and European designs while incorporating American engineering priorities. By the time production models were reaching operational squadrons in 1942 and 1943, the standard configuration had settled around an 80-foot hull constructed from laminated mahogany plywood, a material choice driven not by economy but by engineering. Plywood of that specification was lighter than steel for comparable structural strength, and the weight savings translated directly into speed. 3 Packard Marine engines, derived from aircraft power plant designs, drove these vessels to operational speeds exceeding 40 knots, faster than any torpedo or conventional warship in the theater. The armament package typically included 4 torpedo tubes carrying Mark 13 aerial torpedoes, a 20mm automatic cannon, and multiple heavy machine gun mounts. Ammunition capacity and fuel range were limited by the hull's dimensions, which meant these were not vessels designed for sustained engagement. They were instruments of rapid, concentrated action, followed by immediate withdrawal. The design philosophy embedded in these specifications was essentially asymmetric. A PT boat could not absorb punishment. It carried no meaningful armor protection. A single well-placed round from the medium or heavy calibers used by Japanese destroyers would be operationally decisive. The vessel's survivability depended entirely on its speed and its ability to remain undetected until it chose to act. This created both the challenge and the opportunity. The boats were genuinely difficult to counter, but only if they could operate on their own terms. Motor Torpedo Boat Squadron 9 established its forward operating base at Rendova in the Central Solomons at the end of June 1943. Concurrent with the Allied landings on New Georgia, the base itself was a study in operational minimalism. Fuel storage, concealed maintenance facilities, and a dock arrangement designed to be invisible from the air. The surrounding water was among the most navigationally demanding in the Pacific theater. Charts derived from 19th century surveys frequently diverged from actual reef positions. Watercolor and surface patterns became navigational instruments as important as the compass. The squadron's assigned mission was interdiction, locating and engaging Japanese supply and reinforcement convoys moving through the passage systems between Kolam Bandara and New Georgia. The operational concept was straightforward. The execution, as the first patrols quickly demonstrated, required significant refinement. The initial engagements in early July produced a pattern that the squadron's commanding officers analyzed carefully. PT boats operating with engines at full output generated acoustic and wake signatures that could be detected at substantial distances by trained observers. Japanese destroyer crews and reconnaissance floatplane operators were precisely those trained observers. Early attempts to intercept convoys using high-speed approach runs repeatedly resulted in the boats being located before they could reach firing positions, after which the speed and firepower advantage shifted decisively to the Japanese destroyers. One interdiction attempt on July 5th illustrated the problem with particular clarity. 3 boats attempting to position against the convoy near Visu were identified by a Japanese reconnaissance floatplane before they could reach a viable firing geometry. 4 destroyers responded with searchlights and concentrated fire. PT 158 lost operational effectiveness and did not return. The remaining boats disengaged through the reef passages without completing the interdiction. The tactical conclusion was direct. High-speed approaches conducted in open water against alerted escorts negated the very advantages the PT boat platform was designed to provide. The boats had to find a different way to operate. Over the following 2 weeks, the squadron developed a revised operational approach through iterative experimentation. The modifications were methodical and practical. Engine management became central to the revised doctrine. Running on a single engine rather than all 3 reduced the acoustic signature to a fraction of its full power level and nearly eliminated the bioluminescent wake that tropical waters produced at speed. Approach runs were conducted at 5 knots or below, barely perceptible movement against the background of wind-driven wave action until the moment of engagement. Only then would all engines engage simultaneously. The island geography, which had initially seemed to complicate operations, was reframed as an asset. The radar shadow cast by volcanic terrain masked approach vectors from Japanese shipboard detection equipment. Boats could position themselves in the acoustic and electromagnetic shadow of an island and remain effectively invisible until they chose to move. Inter-boat coordination was addressed through a simple light signal system. Radio communications had proven susceptible to Japanese direction finding, and the noise discipline required for low signature approaches made voice coordination impractical. A prearranged set of shielded light signals, visible only to boats within close range, allowed 3 boat coordinated attacks without electromagnetic emission. intelligence integration improved as well. Australian coastwatcher networks, operating from concealed positions on Japanese-occupied islands throughout the Solomons, provided real-time reporting on convoy movements. Their observations, transmitted by radio to Allied communication centers and then relayed to the squadron, allowed boats to position themselves precisely rather than conducting general area patrols that risked premature detection. Native Solomon Islanders who provided supplemental information on Japanese positions and movements through direct contact with PT boat crews contributed a layer of local navigational and tactical knowledge that no formal chart or intelligence brief could have replicated. By mid-July, the combination of revised approach doctrine, improved interboat coordination, and better intelligence integration had produced a qualitatively different operational capability from what the squadron had deployed with 2 weeks earlier. The interdiction operation of July 19th to 20th, 1943, in Blackett Strait provided the clearest early demonstration of what the revised doctrine could achieve under operational conditions. Coastwatcher reporting indicated a significant Japanese convoy would transit the strait on the night of the 19th, bound for Vila on Kalambangara. The convoy consisted of multiple large transport vessels carrying elements of a frontline army regiment, reinforcements that would directly strengthen the Japanese defensive position opposing the New Georgia landings. Escort coverage included destroyer-class vessels. The logistical stakes were considerable. A successful transit would substantially complicate the Allied ground campaign then underway on New Georgia. 3 PT boats, PT 164, PT 171, were assigned the interdiction. The positioning plan reflected the doctrine developed over the preceding 2 weeks. Each boat was assigned a distinct approach vector relative to the convoy's axis of advance, with the lead vessel threading the corridor between the escort destroyers to reach the forward transports. This geometry was not incidental. It was chosen because it placed the escorts in a position where their own formation constrained their defensive options. Main batteries could not depress to close-range angles without risk to adjacent vessels, and maneuver space in the confined strait was limited. The approach was conducted under the revised doctrine. Minimum engine output, running in the electromagnetic shadow of Vela La Vela's terrain. A coastwatcher transmission at 2347 confirmed the convoy's bearing, speed, and range. Visual contact was established at approximately 018 on July 20th. The convoy was maintaining formation and showed no indication it had detected the approaching boats. The subsequent interdiction lasted approximately 12 minutes. 2 of the 3 transports were removed from operational service during the engagement. PT 171 encountered a more difficult geometry. Searchlights responding to the initial contact located the 3rd boat before it could reach a viable position, and it was forced to withdraw with hull damage. A follow-on torpedo run against the 3rd transport did not achieve contact. That vessel reversed course and returned to Rabaul without completing its transit to Vila. The reinforcement that Japanese planners had committed to the New Georgia garrison did not arrive. The operation had worked precisely as the revised doctrine anticipated, not because of superior firepower, but because of positioning, timing, and the constraints the strait's geography imposed on the convoy's defensive response. The immediate tactical consequences were measurable. Japanese operational records from the period document significant adjustments to Tokyo Express convoy protocols in the weeks following the Blackett Strait engagement. Escort ratios increased, initially doubling, then in some cases tripling. The destroyer assets, assigned to each convoy run. This reallocation reduced the frequency of resupply missions and simultaneously reduced the volume of material each mission could carry, since destroyer capacity was being diverted from cargo to escort function. Float plane reconnaissance assets were repositioned to conduct night sweeps ahead of convoy routes, an additional resource expenditure that further constrained Japanese operational flexibility in the theater. The Japanese naval staff's internal assessments, recovered and analyzed after the war, described the PT boat problem in terms that illuminate the strategic pressure the small craft had generated. The core difficulty was not the boat's individual effectiveness in any single engagement. A single PT boat posed limited danger to an alerted, properly escorted convoy. The difficulty was uncertainty, because the boats were difficult to detect, operated across patrol areas spanning dozens of miles of reef-complicated water, and could remain concealed within radar shadows during daylight hours. Japanese convoy planners could not reliably determine where they were or when they might act. This uncertainty required defensive resource allocation across a much wider area than the actual threat presence justified. Resources committed to broad convoy defense could not simultaneously be committed to other operational priorities. Admiral Tanaka Raizo, who commanded multiple Tokyo Express operations during this period and later wrote extensively about the campaign, described PT boats as a threat that was disproportionate to their physical characteristics because of the planning burden they imposed. A threat that might appear anywhere required preparation everywhere. The technical evolution of PT boat operations during the remainder of 1943 and into 1944 reflected both the lessons of the Solomons campaign and the accelerating pace of American industrial production. Early production boats like those in Squadron 9 carried no shipboard radar. Target acquisition depended on visual observation, Coast Watcher intelligence, and the navigational judgment of crews who had learned to read bioluminescence patterns, wave reflections, and silhouette shapes with practiced accuracy. By late 1943, improved radar sets were being fitted to operational boats, units small enough to install on the PT boat's compact superstructure, but capable of distinguishing vessel-sized targets from background island returns at ranges that exceeded visual contact distance significantly. This capability fundamentally altered the relationship between the boats and the darkness they operated in. Where Japanese night operations had once depended on trained visual observers who could outperform American crews in low-light conditions, radar-equipped PT boats could now identify, track, and position for attack without relying on visual contact at all. Additional improvements addressed the torpedo system. The Mark 13 had performed adequately in the Solomons, but its reliability was sensitive to maintenance conditions and humidity, both significant variables in tropical forward operating bases. Incremental modifications to depth settings and detonator sensitivity improved performance over the course of the campaign. By 1944, improved torpedo variants were entering service with substantially better operational reliability. Hull and propulsion developments reflected operational experience as well. Later production boats incorporated limited armor protection around the bridge and critical machinery spaces, a departure from the original weight minimization philosophy, but justified by engagement data shown that most damage was sustained in the approach and withdrawal phases rather than at the moment of torpedo launch. Engine reliability improvements, partially informed by lessons from mechanics who had diagnosed and repaired failures under operational conditions, reduced the risk of mechanical failure in contested waters among the most consequential vulnerabilities a small boat crew could face. The tactical doctrine codified from the Solomon's experience spread through the PT boat training establishment at Melville, Rhode Island, and through the growing number of forward squadrons operating across the Pacific. Procedures developed through trial and error by Squadron 9's crews, engine management for acoustic signature reduction, radar shadow approach positioning, coordinated multi-boat positioning geometry became the standard framework within which new crews were trained. The institutional knowledge generated by operational experience was being systematically transferred into the force. The operational footprint of PT boats expanded substantially as 1943 moved into 1944. New bases were established in New Guinea, providing interdiction coverage along Japanese supply lines supporting the New Guinea campaign. As American forces advanced toward the Philippines, PT squadrons advanced with them, operating in the island passages of the Western Pacific under conditions that differed in geography but closely resembled the tactical environment of the Solomons. The Battle of Leyte Gulf in October 1944 produced an engagement that illustrated the limits of what PT boats could achieve against the heaviest Japanese surface units, and simultaneously illustrated why those limits were operationally beside the point. A PT boat squadron encountered elements of the Japanese center force, including the battleship Yamato, in the Sibuyan Sea approaches. The Mark 13 torpedo, designed for use against transport and destroyer-class targets, could not achieve meaningful penetration against Yamato's armor belt. The interdiction attempts were not, in the direct sense, effective against those specific vessels, but the requirement to respond to the attacks forced the Japanese formation to execute evasive maneuvers. Time consumed in those maneuvers was time not spent advancing, and in the operational context of Leyte Gulf, where the precise timing of Japanese surface force movements was a critical variable in a complex, multi-element engagement, that time carried strategic weight. The PT boats had not neutralized a battleship. They had imposed an unplanned delay on a strategic operation, at a moment when such delays had cascading consequences. The pattern was consistent across the Pacific campaign. PT boats were not decisive by themselves. No single element of a complex military campaign is decisive by itself. What they provided was a specific capability: rapid, low-signature interdiction in confined waters. That matched a specific operational requirement, and that matched it in a way no other available platform could replicate. Larger vessels could not operate safely in those waters at night. Submarines could not work in the shallow, reef-laden passages of the island chains. Aircraft could not operate at night with meaningful precision in 1943. PT boats could do what nothing else could, in the environment where it needed to be done. Looking back at the Solomon Islands campaign from the distance of history, what stands out about the PT boat program is less the specific engagements it produced than the institutional process that made those engagements possible. The boats were not, in their original conception, a solution to the Tokyo Express problem. They were a capability that existed, that found its operational niche through a combination of tactical experimentation, intelligence integration, and the willingness of squadron commanders to discard approaches that had not worked and develop ones that might. The doctrine that produced the July 20th engagement in Blackett Strait had not existed when the boats arrived at Rendova 2 weeks earlier. It was constructed through observation, analysis, and incremental adaptation under operational conditions. This process, the translation of tactical experience into codified doctrine, the distribution of that doctrine through training institutions, the refinement of equipment based on operational feedback, represents something worth examining carefully. It was not unique to the PT boat program. It characterized American military adaptation across multiple domains during the Second World War. But the PT boat case makes the process unusually visible because the initial capability gap was so clear, the adaptation was so rapid, and the operational consequences were so directly measurable. The Coast Watcher networks, the Solomon Islander contacts, the maintenance crews who kept temperamental engines operational in tropical conditions, the intelligence analysts who processed intercept data into convoy schedules. None of these are visible in the operational record of a 12-minute interdiction in Blackett Strait, but all of them were load-bearing elements of the system that made that interdiction possible. The Japanese naval staff's post-war assessments reached a conclusion that American analysts found instructive. The PT boat threat had been effectively impossible to fully neutralize because it did not depend on a single exploitable vulnerability. Increasing escort ratios reduced the probability of successful attacks, but increased logistical costs and reduced convoy frequency. Deploying hunter-killer groups specifically to locate PT boats diverted resources from other missions. Installing radar on float planes used for convoy escort improved detection capability, but could not cover all operational areas simultaneously. Every countermeasure imposed its own cost, and the cumulative weight of those costs, compounded across months of operational tempo, was itself a form of attrition. The Mosquito Fleet, as it came to be called in both American and Japanese naval accounts, had demonstrated something about the relationship between scale and operational effectiveness that continues to inform naval planning. The assumption that decisive force projection requires large platforms with heavy armament is a durable one, and for many strategic contexts, it is correct. But in specific operational environments, confined waters, complex terrain, supply line interdiction, smaller platforms optimized for those environments can impose costs on a larger adversary that are disproportionate to the resources they represent. The last PT boats were retired from U.S. Navy service in 1959, replaced by successor designs that carried their fundamental concept forward in updated form. Every fast attack craft that followed, purpose-built for rapid strike and withdrawal in littoral environments, drew on the operational experience accumulated in the Solomons, New Guinea, and the Philippines between 1942 and 1945. The waters around Vela La Vela and Colombangara are quiet now. The reef passages that Squadron 9's crews learned to navigate by watercolor and instinct have returned to the rhythms of the Pacific. But the operational principles those crews developed in those passages, approach under concealment, coordinate through low-emission signals, engage at the moment of maximum positional advantage, withdraw before defensive response can be organized, did not disappear with the boats themselves. They became doctrine, and doctrine, once it has proven itself against a capable adversary in demanding conditions, tends to persist.